your best weapon in finding the roots of polynomial with rational or integer coefficients, or with integer coefficients, is to use the rational roots theorem. And the rational roots theorem, let's look at an example here. Let's find all the possible rational roots of the polynomial 2x to the fourth 4x cubed minus x squared minus 6x minus 3. Okay? You can find a discussion of why the rational roots theorem works in the book, and maybe I'll make another video about it, but I think you're probably less concerned with that than how to use it. And the way to use this theorem is, the beautiful thing is that all of the rational roots, if there is a rational root, so a rational root would look like p over q, okay, where p is an integer, okay, and q is a natural number, okay. So any rational root p over q has to, by definition, be divisors of the a0 over an. And in this problem, this is a sub 0, the 0th coefficient, and this is a sub n, where here n is equal to 4. Okay, so in this problem we've got a0 and a4. Okay, so any roots here are going to have to be any roots here. P has to be a factor. P has to be a factor of a0, which is 3. Okay, and Q has to be a factor of a4, which is 2. Okay, we don't need to worry about the signs here because we'll take all positive and negative combinations of the things that we find in our test set. So I'm going to clear the boards here, and we're going to go to town to generate this list. Okay, so that is the main idea, though, is this idea that P has to be a factor. P has to be a factor here, and Q has to be a factor here. Okay, so any rational roots have to look like that. So now let's go to town and see what we can find. So let's start by listing the factors. So P's has to be a factor of 3. So the factors of 3 are 1 and 3. 3 is prime. And 2 is also 1 and 2. So let's look at all the possible combinations of things that we can make from that. Okay. Well, first of all, we can have 1 divided by 1, which is 1. So we can have plus or minus 1. All right. We can have plus or minus 1/2. We can have 3 plus or minus 3. Now these are not in normal order. We can reorganize these in a second, and we can have plus or minus 3/2. Okay, and that is the set. So let's put these in some kind of numerical order for the sake of being compliant. When you going through the list and you're making all possible combinations, so this is these are going to be the numerators, these are going to be the denominators. Okay, so that's how we think about it. These are the factors. So set up yourself a little table and then work your way through. So we can have plus and minus 1/2. We can have plus and minus 1. We can have plus or minus 3/2, and we can have plus or minus 3. These are the only possible rational roots of our original polynomial equation. And that's kind of cool. So that means that you only need to use synthetic division to go through and test each of these 8 possibilities. Okay? And that's a great theorem, and that's how you produce the list, and then you just go through the list with synthetic division, and figure out who's a root, because when you divide by that, you're going to get a remainder of 0. That's the factor theorem. So hopefully you know the factor theorem, and now you know the rational roots theorem and how to work it. Okay.